Looking at example 16, Joe lives frugally, saving every penny he can. He has a master plan to retire when he's 42. He wants to be able to take $4,000 every month for 45 years from his retirement account, and his account earns 7.5% interest. So again, here's our clue. He's going to take money every month from an account. So this is what says we need to be using our formula for our payout annuity. So how much money will he need? So what is the principal or the total amount he will need to reach his goal? He wants to withdraw $4,000 every month. He wants to have, or his account, is earning 7.5% interest, and he's going to withdraw every month, raised to the negative, don't forget your negative, 12 times. And how long does he want to take this money out? Well, he wants to keep drawing on this money for 45 years. Now that's a long time, but remember, his master plan is to retire at age 42. And then we need to divide all of that by the interest rate over how many times a year he's planning on taking this money out. Very carefully entering that into your calculator. It turns out that Joe needs to have $617,869.18 saved up when he retires. Now, assuming he does that, how much interest is it that he's going to earn? Now remember, this is a little different because he's going to withdraw more than that $617,000. He's going to withdraw $4,000 every month for a total of 45 years. Okay, that's a lot of money that he's going to withdraw. And then if you subtract what he started with, that $617,869.18, you will find out that Joe is earning more than $1.5 million in interest after accumulating the $617,000 in his retirement account. Again, a lot of that's going to be interest. So again, put your money to work for you. That's like the one thing I can tell you. Let your money work for you. All right, moving on to example 17. Maya knows that she will have $750,000 when she retires. She wants to be able to take monthly withdrawals. So again, there's your clue as to which formula it is you're going to need. She wants to do that for 35 years, and her account is earning 8% interest. How much can she pull out each month? Now, in this case, we know the starting amount. We know that she has saved up $750,000 in her retirement account. We want to find W, that monthly withdrawal amount. So continuing with the formula, we need to put in our interest rate of 8%. Those are monthly withdrawals, and she's going to withdraw that money for 35 years. And so just like with some of the problems in the earlier section when we were going to find the deposit amount, how much money are we going to set aside every month? Now we want to find the withdrawal amount. So notice that W is not isolated. W is being multiplied by this number here on the right-hand side of the equation. When you type that into your calculator, again, no rounding and all of that good stuff, you get 140.793 and a whole bunch of other decimals. Using that copy and paste function on your calculator, 750,000 divided by that 140 point number, you can find out that Maya can take out $5,326.96 every single month from her retirement account. That is a lot of money to be able to live on a monthly basis in retirement. All right, and then the last one here on this page. An alumnus of a university gives $450,000 to the university, saying that the money is to be used to give annual scholarships for the next 30 years. Okay, so again, we're giving annual scholarships. That means we're taking money out of this account to give to students who deserve it. Okay, so If they're going to invest the money at 4%, how much could they give in scholarships, take out of the scholarship account every year? So we're going to start with that $450,000 in the account. That's your principal. The question is, how much can they take out on a regular, in this case, yearly basis? 4% interest, and we're only going to do that once a year. We're going to give out scholarships every year, so once a year for 30 years. They want this money to last 30 years. So 0.04 over 1. Now please notice that 0.04 divided by 1 is simply 0.04. Okay, there's no need whatsoever to type that divided by 1 in your calculator unless for some reason you really feel the desperate need to do so. That number on the right hand side that we're multiplying by the W turns out to be 17.292 and a whole bunch of decimals after that. So dividing both sides of the equation by that 17.292 number, the university can award $26,023.54 worth of scholarships every year from this particular fund. Whether that goes to one student or a whole bunch of students, that's up to them, but that's how much money that they've got to play with on a yearly basis for the next 30 years.